Hi, my name is Jennifer, and in this video, I'm going to show you how to simplify a cubed root or higher when it contains variables. So grab a pencil and paper and work through these problems with me. Let's take a look at this first problem. We have the cubed root of 27a to the fourth. We're going to work through the same method that we've done on previous videos. We're going to make a factor tree out of 27a to the fourth. So 27 is 9 times 3, and 9 is 3 times 3. And then we'll bring down this 3. And a to the fourth simply just means that there's 4 a's multiplied together. We'll put those down here. Next, now we need to see if we can find sets of 3 of the same number, because this is a cubed root. Notice that we have 3 3's, so we can call that a set of triplets. And we have 3 a's, with 1 a left. Now to write our answer, we're going to represent each of these sets of 3 numbers on the outside of our radical. So we have a set of 3, and we have a set of a's. Those will be written together as a multiplication problem. Then we'll draw our cubed root radical sign, and whichever number or letter that was not part of a triplet set stays underneath the radical. So we'll put the a back underneath. So the final answer to this problem is 3a times the cube root of a. Okay, let's work another example. This one is the cubed root of 8x to the fifth y squared. Let's go ahead and make our factor tree. Four times 2 is 8. 2 times 2 is 4. Then we'll bring down this 2. Our exponents, x to the fifth, means that you've multiplied x times itself 5 times. We'll write that below. Y squared means that you've multiplied y times itself twice. Okay, now we're ready to look for groups of 3. Notice that we have 3 2's, and we have a set of 3 x's with 2 left over, and we have 2 y's left over. Now we're ready to write our answer. We're going to represent each set of 3's. We're going to represent each group of 3 numbers on the outside of our radical. We have a set of 2's, and we have a set of x's, and those go together by multiplication. Next, we'll write our cubed radical symbol, and any number or variable that didn't make it in a set of 3 goes back inside. Notice we have 2 x's and we have 2 y's. X times x is x squared. Y times y is y squared. So the final answer to this problem is 2x cubed roots of x squared, y squared. Okay, let's try one more problem together. This is the fourth root of 80 y to the seventh. Let's first start by making our factor tree. 80 can break down to 4 times 20. 4 breaks down to 2 times 2. And 20 breaks down to 4 times 5. We'll bring this 2 down and this 2. 4 gives us 2 more 2's. And then we'll bring down this 5. Remember, this bottom line needs to equal 80. Next, we have y to the seventh. That means that there's 7 y's multiplied together. Now that we have all the factors together, we can start looking for our groups. Because this is a 4th root, we'll be looking for groups of 4, or quadruplets. Right here we have 4 2's, and we have a set of 4 y's. We're ready to write our answer. We're going to represent each group of 4 numbers on the outside of our radical. We have a set of 4 2's, and we have a set of 4 y's. Then we'll put our 4th root symbol, and anything that did not get grouped up with a group of 4, it goes back inside of the radical. Notice that we have a 5, and we have 3 y's. 5 goes on the inside. Y times y times y is y cubed. So the final answer to this problem is 2y, 4th roots of 5y cubed. If you have any other questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.